In this video, we will solve some numericals regarding Archimedes' principle. We have the first question. It states that an aluminum cube has a volume of 800 cubic centimeter. If it is totally immersed in water, calculate the up thrust acting on it. 1 gram mass is equal to 0.01 Newton. So basically here we use the principle of Archimedes. So in your solution part, you can write that the upper thrust is equal to, it is the same as the weight of the fluid displaced. Weight of the fluid displaced. This is what we know. But we know also that weight of the fluid displaced, it is the same as mass of the water displaced times gravitational force. And also, mass of water displaced is density of water times the volume of water. So we can also write that density of water times the volume of water times gravitational force. Also, we know that the volume of an object, in this case, which is the cube, volume of the cube, this will be equal to the volume of the water displaced. So this is the same as volume of water displaced. So now we can calculate the upper thrust, because we know the density of water is 1. This is gram per centimeter cubic, times volume of water. This is the same as the volume of the cube, which is 800 cubic centimeter. This is cubic centimeter, times the gravitational force. It is given as 0.01. This is it, Newton per gram. So this gram and this gram cancel out, centimeter cubic and centimeter cubic cancel out. So the answer here will be 80 Newton. This will be our answer. The second question, it says that an iron piece of mass 360 gram and a density of 6 gram per cubic centimeter is suspended by a rope so that it is partially submerged halfway in oil of density 0.9 gram per cubic centimeter. So the question is asking to find the tension, which is the same as force in the string. So we can try to understand this question by drawing the simple diagram. For instance, you are having, this is now the beaker, for instance, and inside here there is oil. This is oil, and you are having the string which is suspended there, and this string actually it is having the object which have the mass of 360 gram. So we can say that the mass of iron, we can let that mass of iron, let us say mass of iron, which is Mi, this is equal to, it is 360 gram. But also we understand the density of the iron, so we can say density of iron, which is Di, this is equal to 6 gram per cubic centimeter. So it is halfway submerged, and in the oil of density 0.9 gram per cubic centimeter. So we are having also the density. This is the density of oil, which is DO, is equal to, this is 0.9 gram per cubic centimeter. Now the question is asking to calculate the tension in the string. Basically the tension in the string, it is the same as the apparent weight. So basically here we'll be calculating the apparent weight. So in order now to calculate the apparent weight, we must know the weight in air, which is the real weight, and the upper thrust. So let us now first calculate the upper thrust. This is upper thrust will be equal to, because the object is halfway submerged, we can take a half times mass of the oil displaced times the gravitational force. So this is the same as taking 1/2 times mass of the oil. It is the same as taking density of oil times volume of the oil times the gravitational force. So we can multiply and get 1/2 times density of oil. It is given as 0.9. This is 0.9 times the volume of oil. It is the same as the volume of the object. So in this case, you must understand the volume of the iron. If you get the volume of one iron, then it will be the same as the volume of the oil. So let us now calculate the volume. Can you say that? Now let us say volume of iron. This will be equal to, because density is mass over volume. So volume of iron, it is mass of iron. We divide it to the density of iron. We are having the mass of iron, which is 360 gram. 360 gram divided by 60. So we will get 60 cubic centimeter. This will be the volume of the iron, which is the same as the volume of oil. So now we can calculate the upper thrust by taking 1/2 times the density of oil times the volume of oil, which is the same as the volume of iron, which is 60, times the gravitational force here. It will be 0.01 Newton per gram. So if you calculate there, the answer will be 0.27 Newton. This is the upper thrust. But also, let us calculate the weight in air, which is the real weight. Now the real weight will be obtained by taking the mass times gravitational force. So the mass of the object, it is 360 gram times the gravitational force, it is 0.01. This is Newton per gram. So if we multiply there, the answer here will be 3.6 Newton. Now in order to calculate now the tension in the string, we calculate basically the apparent weight, because we understand that the upper thrust is equal to weight in air minus apparent weight. So the tension now, which corresponds to the apparent weight, will be equal to weight in air minus the upper thrust, which is equal to the weight in air here is equal to 3.6 minus 0.27. So the answer here will be 3.33 newtons. So this basically will be the tension in the string. All right? Okay. Let us see the last numerical. It says that a body lost 0.6 Newton in weight when immersed in water. Calculate the volume in cubic centimeter. So the solution also of this question is done by considering the principle of Archimedes, whereby we understand that basically the upper thrust is equal to weight of fluid displaced. So because this body lost 0.6 Newton, this will be the upper thrust, which is the same as the apparent loss in weight. So in this case, the upper thrust is given as 0.6 Newton. Okay? Now let us calculate the volume, because we know that upper thrust is given by weight of the fluid displaced, which is the same as taking mass of water displaced times gravitational force. So this also can be obtained by taking density of water times volume of water displaced times the gravitational force. But the upper thrust is given as it is 0.6.
This will be equal to density of water, which in this case you can use 1,000. This is 1,000 kilogram per meter cubic, times the volume of water, it is the one which we are required to calculate, times the gravitational force, which in this case is 10 Newton per kilogram. So if you calculate the volume here, it will be 0.6 divided by it is 1,000 times 10. So the answer here will be 0.00006 meter cubic meter. So the question is asking you to calculate the volume in cubic centimeter. We understand that basically 1 cubic meter is equivalent to 1 million, 0.000 cubic centimeter. So how about this cubic meter, which is 0.00006 cubic meter, will be equivalent to how much cubic centimeter? So if you calculate here, you will end up with the volume is equal to 60 cubic centimeter. Thank you for watching. Don't forget to subscribe, and see you then in the next video.